Folks, hello, welcome. Hope you had a nice lunch. My name is Jerome Dolphin, and I am a technical marketing engineer with the SD Access team inside of Cisco. So for those that don't know, very briefly, we're essentially an interface between real users and the engineering folks that write the code, create the protocols, create the hardware. So my job is to help you all understand how the technology works and then learn from you what else is needed from the technology and give that back to engineering. So it's a very fortunate position. I get to talk to lots of interesting people and always learning something new. My focus predominantly is SD Access. However, in that SD Access journey, discussions invariably move from campus networking to what do we do outside of the campus. And so that's the genesis of this discussion today, multi-domain segmentation. There's a room. I've put the PowerPoint in the room in PDF form. I've also put all the demo videos in the room. People ask for those every year, so this time I've just got ahead of the game. Download the MP4s and use them as you see fit, please. Today, we will be walking through how we achieve multi-domain segmentation. For better or worse, I've made this a little bit of a different kind of presentation. Some people love it, some people don't. But this will be a theory and then do kind of presentation. So pretty much every section includes a demo. For the first time ever, this presentation's been running for a few years now. For the first time ever, there is a tiny bit of roadmap in the final section to give you a view of where we see ourselves going in the next 6, 12, 24 months. But for the most part, it's theory and then do, and then theory and then do. And hopefully by the end of it, we'll all be in a better place. The deck is big. Last year, after going 15 minutes over with audience permission, they basically said at the back of the room, look, we're going to cut the mic, you need to get out. So this year, I've tried to anticipate a few questions, not too many, I hope. And there is hidden slides in the deck. So if you download the PDF, you'll find more content that is discussed today because we just can't get through it in an hour and a half. But hopefully some of that hidden content will be useful for you in learning and speaking to your customers and partners. As I said, this is a learn through doing session. So theory, do, theory, do. This is an end-to-end discussion. So while I spend my time in SD Access, obviously the security proposition from Cisco spans the entire networking stack. So we will be doing cross-architecture discussions into LAN, WAN, data center, and security. That means that I can't go particularly deep into any given topic domain. We're not going to look at firepower appliances and what models they have and how far they scale. That's out of scope. You can go to all of those various discussions to go deep on any particular thing. So we're going broad, not deep. I've had to make some assumptions about your general level of knowledge with networking. This is recorded. Every section has references to other material that you can use to dive down to learn more about SD Access or firepower, or ACI or whatever. But we won't be going deep into all those topics. There's just not enough time in 30 minutes. All right, so just a disclaimer before we get started. I've built what I consider to be a standard multi-domain infrastructure, and I'll walk you through it. However, of course, as is always the case, there's always another way to solve a problem. So I'd like to think of today as really a demonstration or a discussion of the art of the possible. And then if you're not satisfied with a particular way I've achieved something, I don't want to use that routing platform, I have some other vendor's WAN, or whatever the case may be, hopefully by the end of this, you know what's possible, and then it's a discussion, with a partner or a CX or your sales team. Hey, we saw this presentation, we like the outcome, but we differ in some way. But obviously, knowing what questions to ask is a good start, and then the variations, we can't cover all permutations in 90 minutes, but I'll give you an idea of what can be done. Now, because this is a theory then do discussion, it is based on a lab infrastructure. Cisco have furnished a lab, which we will use throughout this demonstration. So it's all real stuff. So we'll just jump into very quickly what the lab looks like, and then we'll get into all of the various outcomes. For those that don't know, software-defined access is an automated campus LAN networking solution. That means instead of configuring switches and WLCs on CLIs and UIs, instead we use an orchestration engine, Catalyst Center, previously known as DNA Center. Inside of Catalyst Center, we put in our business intent. I want this quality of service, I want this virtual network, I want this segmentation outcome. Catalyst Center converts intent into configuration and deploys it into the wired and wireless campus LAN network infrastructure. Now that could be one switch, hundreds of switches, or potentially many thousands of switches, tens of thousands of wireless access points, one wireless access point, whatever. You can break these things up into different domains. There's different size Catalyst centers. You can run multiple Catalyst centers, so it can scale from quite small to quite large, depending on requirements. Catalyst Center is a mandatory component for SD Access. There is, we call an SD Access site a group of devices working together to deliver connectivity outcomes. We call that a fabric site. Within a fabric site, we have a few mandatory components, a fabric border node, BN, that connects an automated SD Access campus LAN, so the domain of automation that connects it to the non-automated domain, the outside world, the external network. Might be a service provider, a firewall, your existing core, whatever it may be. Border nodes connect SD Access to not SD Access. Fabric edge nodes connect things like IoT devices, cameras, PCs, printers. The fabric edge nodes are in essence your access switches in the traditional network. And then there's a control plane node, which is a longer discussion. We won't go into the depth today, but a control plane node is in essence a Lisp database that tracks what things are connected where. I mean, from your perspective to provision a control plane node, it's a click in the UI. Under the hood, it's configuring Lisp database to attach and track endpoints as they connect into the network and move around the network. So those were the mandatory components for SD Access. We also have optional components. Identity Services Engine is technically optional, and there is some deployments out there that don't use it. ISE will, however, be very important for the majority of this discussion we're doing today. Micro-segmentation and sharing segmentation context is a function of ICE, but I mentioned that it is optional because technically it is. However, if you're doing multi-domain segmentation, ICE realistically is mandatory. Fabric-enabled wireless, so automating the wireless network into the SD Access fabric is optional. Generally speaking, if people are deploying a new network, they'll do wired and wireless. Maybe if you're doing a legacy network migration, perhaps you'll start with wired and tackle wireless as a second-order activity. It just depends on migration timelines, risk tolerance, scale of work, and so on. And then finally, in the SD Access fabric, we have this concept of intermediate nodes. They are optional. An intermediate node is just a big router. It's just moving Lisp and VXLAN between different devices that have been automated by Catalyst Center. You can have 0 intermediate nodes. You can have 5, 10. It doesn't really matter. They're just routing packets between fabric roles. Fabric roles can be consolidated if you need. So you can have a border and control plane in one switch, border control plane edge, or a border control plane edge and embedded wireless LAN controller. The platforms you choose to implement these functions and the level of consolidation you do is defined by scale and performance, obviously. You don't put a 9300 fabric in a box with wireless LAN controller in a site with 100,000 endpoints. It makes no sense. It can't scale to that performance. But for a branch, with 50 or 100 or 200 endpoints, perfectly fine to have a fully consolidated function into one switch. Technically speaking, there's 2 ways we can deploy SD Access today. We'll be focused on Catalyst Center automation for this discussion, but just so you know, and if you want to investigate this further, it's a discussion with your sales or CX team. We do have our configuration models published as a CLI configuration guide. So if you love Lisp and VXLAN, but you have your own homemade automation solution that the business is married to, then you can take our Ansible playbooks, or you can take the CLI configuration guide and feed the SD Access configuration models into that. We won't discuss that component of SD-Access today, but the concepts we're presenting, SGTs, virtual networks, border nodes, it's equally applicable to both deployment methods because it is just SD-Access. All right, so the lab that today's discussion will be based on contains an ISE cluster, a node of 1 in this case, and a Catalyst Center cluster, a node of 1. I have pre-provisioned 3 SD-Access fabric sites. I call them West, Central, and East. This diagram is in the PDF in the Teams room or the WebEx room. You may possibly need to refer to the diagram occasionally. It's up to you. Potentially, if you're trying to understand what I'm saying, maybe the topology makes sense. I have brought in, since it's a multi-domain discussion, I've opened the door to some Meraki stuff in the discussion. So I've brought in some Meraki wireless access points in one site. The other site on the right-hand side is running Catalyst Center automated fabric wireless. We'll get into what that means and what it looks like later. There is endpoints attached, E, C, and W, West, East, Central, and West. So the first letter indicates the location, and then the second chunk of letters indicates the function. It's a BMS device, staff device, CCTV device. I've also got a few real devices attached, so real devices are hard to come by in a lab. They're a bit trickier, but I do have an Apple TV, a Meraki camera, and a Cisco IP phone that will be relevant later. I have an ACI implementation configured. It's quite basic, but it's enough to prove a point. For those that don't know, ACI is a Cisco software-defined data center solution, also controller-based data center automation. We have some stuff in AWS as a hat tip to public cloud, which will be part of this discussion. I have it says East DC, but what it represents is I have an on-premise server room or a small block of compute within a fabric site that I want to connect to my SD-Access and apply policy to. There's a routing aggregator, otherwise known as a fusion device often, or peer device, depending on what SD-Access discussion you've been to. I have Cisco SD-WAN. I have a traditional WAN, so this is just dark fiber, really. There's some other stuff in this services block. We'll get to what those things mean later. We'll get to Umbrella and XDR. We're going to put all this stuff together. There's a Cisco secure firewall, other known as FTD, Firepower Threat Defense. I'm not quite clear on, apparently it's called Cisco secure firewall, but it's okay to say FTD, so excuse me as I chop and change between these terms. Language changes are very hard to internalize after I've been saying Firepower for 10 years or 15 years or however long it's been around. There's also some internet and some services on the internet. We'll be referring to those throughout the discussion. The routing configuration is important. This is a segmentation discussion, what we're having today. So there's 2 levels of segmentation, macro segmentation and micro segmentation. Macro is isolated routing tables or isolated VLANs. We'll get a bit more into it. But on this peer device, this fusion device, this IP core, this is manually configured by template. We've got some routing tables. In GRT is our services block. In the fabric sites, I've configured some virtual networks, so corporate and IoT. Obviously, SD-Access can contain many more, but this is enough to prove a point. We will build a back-to-back routed interconnect between East and Core. We will add our on-prem data center. We will add our SD-WAN infrastructure. It's also subdivided into virtual networks, so we can keep corporate traffic separate from IoT traffic, separate from network management traffic, which is global routing table. ACI has a VRF that connects into a VRF in the fusion device, and then the Firepower Threat Defense has a leg into all of these VRFs. So it is doing inter-VRF or inter-VN policy. We'll get into how to use Firepower to achieve micro-segmentation between different policy domains. That's a bit further into the discussion. AWS is there. It's reachable through the Cisco network. It's very heavily restricted. This lab is in the Cisco network, obviously. AWS is reachable from the lab. It's very heavily restricted due to Cisco security policy, but it is there. We'll do some mucking around with AWS. The firewall, as I said, has a leg into each network. It is routing in and out. It will be applying policy. Please you don't need to remember prefixes or routing information. I've just put it here for completeness. And if you're looking at the slides in 6 months from now, maybe you'll be wondering where was that IP address. So the routes are there, but you don't need to remember them. Endpoints are assigned. We'll look at the ICE policy in a minute, but you can see on the left-hand side, endpoint names, they are being assigned into a virtual network in SD-Access or an ACI, and they're being assigned an SGT or an EPG or an AWS SG. In other words, they're being assigned a segmentation object that we will use to apply policy. We'll get into all of those things and what they mean. This is a reference slide, again, in case you're coming back to look at this later. Now, throughout the discussion, I'm targeting a particular segmentation outcome. I just need a target to hit. It's kind of arbitrary. It's just something common sense that I constructed from imagination. The segmentation policy is in the hidden slides. It's not really important from the sense of the concepts we'll be discussing. It's just there in case you're wondering, why did he segment A from B? I just needed to give myself something to hit. All right. Okay so far? All right, so I'll give you a quick view of what the lab setup looks like. The Mac has been a little problematic at times, and the last 2 Cisco Lives, for anyone that's been here, this thing has crashed. It doesn't like HDMI, so let's hope we don't have a repeat incident today. All right, so I'll show you what the lab looks like, and then we'll get into building our multi-domain policy. I have a Catalyst Center, unsurprisingly, and in that Catalyst Center, excuse me, we have some basic design configuration. I'm actually making a video series now, how to deploy SD-Access from scratch. That'll go up onto YouTube soon. So this is kind of like a preview of that. I'm just walking you through some of the major stuff, and then you can get a sense of what's going on here. In Catalyst Center, the first thing we build is a network hierarchy that represents our SD-Access fabric sites. So you can see here, I'm Australian, so I put it in Australia because I can. But you can see here, we have our 3 sites, West, Central, and then East is the number 3. It's 3 buildings. So I probably need to put a UI feedback on this. I'd prefer if it said the site name, but when there's multiple objects in a site, it shows a number. So East is the number 3 in this particular topology. We have an ISE integration. I've already done that. I've actually, as part of the how to configure SD-Access, I've got an ICE integration demo as well. Again, not out yet, but should be on YouTube in the next few months. I'm sure it will be well announced once it's there. You can see here, AAA client endpoints, ICE, radius, and we're nominating a primary server, a PSN. So in other words, what we're saying to Catalyst Center is use ICE for closed authentication access to the wired and wireless SD-Access infrastructure. So ICE will be doing .1x and MAB over radius. That's essentially what this means. There is a wireless SSID configured. It's JEDOLPHI-SDA. I just put my username into the SSID so that if someone in the lab wants to complain, they know who to go to complain. There's like 100 SSIDs in the lab, so, but that's a fabric SSID configured through the Catalyst Center automation. Okay, we have our fabric sites as shown on the diagram. So here we can see fabric site East, Central and West. There's some other ones there. We won't worry about those for the discussion. If we look at East, I've already discovered the devices and provisioned those SD-Access roles. So we can see there we've got border, control plane, and edge nodes, and a fabric wireless LAN controller, the WC, on the right-hand side. In the Central site, we have our 3 switches as shown in the diagram. I've just chosen different topologies just to prove a point. Here we have a fabric in a box. So all of the roles provisioned into one, Catalyst 9300, and then, beg your pardon, and then 2 other fabric edge nodes downstream from that. Again, just proving a point of various topologies that can be achieved. For the final site, we have West, and here we can see that it is a fabric in a box plus a WC, a wireless LAN controller. So it is running a Catalyst 9300 embedded WLC, meaning it is providing wired and wireless SD-Access functionality. There is one fabric AP registered to the WLC hosted in the Catalyst 9300 fabric in a box. All right, so in the group-based policy menu, This is what we'll be spending a bit of time on today. This is micro-segmentation outcomes for the SD Access Fabric. We'll talk about SGTs in a minute, what they are, but SGTs represent roles of devices on the network, and we can segment roles from roles. I don't want my guests talking to my contractors, or maybe a better example, for those that have, there was a well-publicized, just an example, there was a well-publicized breach of a retailer some time ago where a credit card reader was compromised, and then it can move east in the VLAN to other credit card readers and spread that compromise. Obviously, you can extrapolate to whatever system. It doesn't have to be a credit card reader. It could be IoT or some other critical infrastructure. So obviously, we want to segment things from things. This is where we do it. We'll get into that a little bit later. For now, there is no segmentation policy. All the cells are gray. That means default policy. And in the top right corner, we can see that it says default permit IP. So in other words, anything can talk to anything within the campus LAN by default. You can change that to deny, so nothing can talk to nothing. Deny is a little bit more complicated, and just a word of the wise, you never ever transition, well, there's always an exception to the rule. Typically, you don't transition to deny all in a production network that is asking for trouble unless you're extremely confident on how the network behaves. Usually, a deny all is a day zero policy implementation. Then you start adding stuff, so you know that the thing never worked to begin with. But sometimes when you flip to day, I'm getting off topic. Turning on deny all on day N is risky stuff. It's not impossible, but it's important to be aware of the possibility that you don't know that endpoint A talks to endpoint G because nobody knows. And when you turn on deny all, suddenly something stops working. All right, for now, it's default policy. We'll get to policy changes in a minute. Finally, ISE, which is integrated to Catalyst Center. We can see here, if we go to our policy sets, what this represents in ISE, for those that don't know, in authorization policies, is a set of rules about what is allowed into the network under what conditions. So if we look at the second row down, for example, it says wired 802.1x corp VN. That rule is saying if an endpoint is connecting with wired 802.1x and it is part of a particular identity group, if the credentials map to a certain level of privileges, then that endpoint is allowed into the corp VLAN with an SGT of employees. These policy sets are processed from the top down. ICE will read down the list until it finds a match, and then it will apply that authorization profile, VLAN and SGT, to those credentials. At the bottom, of course, you would typically have a deny. So if you don't match any known credentials, you're not allowed into the network. Some folks might change that to you go into some quarantine or restricted access network, possibly, or you can apply an ACL or whatever the case may be. I've pre-built these policies so that things are already connected into the network. And then finally, if we have a look at our TrustSec dashboard, what it's saying here in ICE is, reading from the left-hand side, identity. So we have usernames and MAC addresses of wired and wireless endpoints that are already connected into the SD Access Fabric. We can see there that there is a security group, so the SGT that has been applied to that endpoint. So the top one, the staff ID, has received the employee's SGT, and it's got an IP address there of the endpoint, in case you need to know it. That IP address is handed off to other systems. We'll get to that a little bit later on. All right, so that's just an orientation, and then we'll get into the actual building of the multi-domain stuff. Go ahead, my friend.
What version of Catalyst Center are you using?
What version of Catalyst Center? That's 2.3.7, which is almost out. Yeah, any day now, don't quote me. But no, it's close. All right. Okay, let's get on to it. So transits and segmentation. I mentioned that there's references in each section. Obviously we can't cover all this content. These are hyperlinks. So if you grab the PDF and you click on the hyperlink, then you can go to the document or the Cisco Live presentation and have a look at it. There's a CVD, obviously. There's Mahesh, one of my colleagues, design best practices, so on and so on. Feel free to go through that if you'd prefer to, if you want to dive deeper into those particular topics. Now, segmentation within the campus LAN. I've already touched on this. There's layer 3 virtual networks. They're isolated routing tables. In other words, for anyone that's done VRFs manually, VRF Lite, MPLS VPNs, if you're familiar with those concepts, it's the same thing. A virtualized routing table cannot jump into a different routing table. It's isolated inside of the IOS XE. So if I put an endpoint into corporate VN, that endpoint can't jump across to IoT. Or if I put a guest into guest VN, it can't jump across to whatever else. The idea, obviously, is when things should never, ever speak to each other, and they are generally separate administrative or policy domains, you can break them into VRFs. It's a delicate balancing act, though. You can go too far with layer 3 virtual networks as well. If you split every app into a layer 3 virtual network, then you end up with massive sprawl. But in principle, they're isolated routing tables for things that should never touch each other. A layer 2 virtual network is a layer 2 segment in SD access. So you can think of it to being analogous to a giant VLAN. If a packet goes into a layer 2 virtual network, it has to exit that same layer 2 virtual network. It can't hop across to something else within the SD access fabric. So that's macro segmentation. And then within our layer 2 and layer 3 virtual networks, there's the concept of micro segmentation. So micro-segmentation uses SGTs, or security group tags. You've probably heard this language. It's been around forever. SGTs existed before SD access. It's just that we've leveraged them in the SD access architecture. You saw in the ICE authorization policies, a thing connects in, it presents credentials. Credentials might just be a MAC address, or it might be something more advanced like an 802.1x session, a certificate, a posture, some vulnerability state. I mean, for those that haven't played with ICE, the potential match criteria is immense. But endpoints present credentials of some combination. Those credentials are matched in ISE. ISE sends back an access accept with an SGT ID. In this case, it's assigning SGT 5 to this endpoint, and the port opens up into VLAN A, B, C based on your ICE policy. On the right-hand side, I've got two other devices. So I've got a lighting device and a HVAC. In my mind, I'm thinking this is a motion sensor that's going to wake up a lighting device, as an example. So SGT 5, 20, and 30. These endpoints are not aware of what SGT they've been assigned. This is all functionality within the SD access fabric. So endpoint on the left is talking to endpoint on the right. It originates an IP packet with a source and destination IP address. The SD access architecture looks up the destination, attaches the SGT, the source SGT, to the payload, builds a VXLAN tunnel, which is just native to SD access fabric. We route to the destination. At the destination, we know the source, SGT, 5, it's attached to the packet. We know the destination SGT because there is a session for that destination endpoint on a given port. And so we know it is, for example, 5 to 20 or 5 to 30. Now, I showed you the group-based policy matrix before, the matrix of cells that were all gray. Source SGTs to destination SGTs was the default policy. So in this case, in this hypothetical example, we're saying camera can talk to the lighting device or the motion. So that is permitted. If the camera was sending a packet to the HVAC device, as an example, that would be denied. So that policy is distributed from Catalyst Center through ICE down to the wired and wireless network infrastructure in our one or many fabric sites. Now, in this particular instance, we're jumping between fabric edge nodes, but this policy is equally applicable in all permutations of traffic flows. So two endpoints in the same VLAN on the same switch can also be micro-segmented. The same SGT can be allowed to disallowed from speaking to itself. So for example, credit card reader to credit card reader, you can block that. It's the same SGT in the same VLAN on the same switch, but they're not permitted to talk because typically the credit card reader will be going north towards some sort of server in a data center or some cloud asset. There's no reason for these things in this hypothetical example to move east-west. Policy applies to the same VLAN, different VLANs, wired, wireless, same access point, whatever combination is. It is the same microsegmentation policy in the SD-access fabric. That's one of the value propositions. What you'll also notice here in this group-based policy is there is no reference to IP addresses. So think about networks with thousands, tens of thousands, hundreds of thousands of endpoints. There's no need to manage ACLs of source IP X to destination IP Y. We abstract that away, the complexity of ACLs, which can be very difficult to manage and maintain. We move that up a level to the actual intention of policy, which is to separate functions from functions within the SD-access network. Go ahead, please.
Is traffic stateful then? So will I get a return path or will an SGT?
Is traffic stateful? Not within the trust seg domain. So this is massive segmentation at scale, but to your point, it is not stateful. You can match a SYN and a SYN-ACK flag, but that doesn't really qualify as stateful in my mind. That's a bit of a hack. So we do stateful stuff on firewalls, and we do stateless microsegmentation within the SD-access architecture. So, well, how does a return packet get back? We need to permit packets in both directions. So A to B and B to A both need to be permitted to each other. If it's within the SD-access architecture, if we're moving between virtual networks, we'll get to that in a minute, then we can route through a firewall and we can have network state as packets move. But this is really for massive segmentation at the access layer. And if we think about the equivalent, I have 100 endpoints on a layer 2 switch in a closet. They're all in the same VLAN. How do I segment those today? Well, I mean, you could deploy PACLs or RACLs or VACLs or whatever, but that's just a headache. So this is a step up from port-based ACLs, but to your point, it's not stateful, but we do stateful somewhere else. Cool, all right. Okay, so we've got segmentation within the campus worked out. We've got our virtual networks for macro segmentation and SGTs for microsegmentation. How do we move segmentation between fabric sites? So obviously you may have 100 branches, or you may have multiple buildings in different cities, or whatever the case may be. Each of those is typically a fabric site. You don't want to lose microsegmentation or macro segmentation context as traffic moves between locations. So we have IP-based transit. It's just a standard SDA automation framework. You say these virtual networks hand off on these IP addresses, SDA border nodes peer BGP to some external routing system. It's then your job in that gray cloud there, if you're using IP-based transit, it is your job to make sure those VNs stay segmented or those SGTs move from left to right-hand side. So this is one option. This is the manual option. It's perfectly valid, but we need to know pros and cons of our options, of course. There is SD-access transit. SD-access transit is automated by Catalyst Center. It will interconnect virtual networks, but in different fabric sites, and it will natively preserve virtual network, VN, and SGT IDs as packets move between locations. So in other words, it VXLAN tunnels traffic from left to right or up and down. You don't need to deal with maintaining routing table isolation and SGT propagation. The final choice is SD-WAN transit. This term has been a bit loose. I should probably rename it slightly. It is really an IP-based transit using Cisco SD-WAN. In the case of the Cisco SD-WAN architecture, you can create VPNs for routing table segmentation, and assuming you're using latest generation Cisco SD-WAN infrastructure, it will also tunnel SGTs within the SD-WAN fabric. So SGTs enter router 1 and they pop out of router 2 on a data plane. We'll explain it in a minute. Now we saw before in the policy, it's source SGT to destination SGT. That means both need to be known in order to apply a correct policy. If the source SGT is lost, then we don't know what policy to apply to a particular transaction. This means that SGT preservation is important. Now, the way we can scale group-based policy in the campus LAN specifically is to apply policy at egress. That, if we try to apply policy at ingress, my destination could be one of thousands or tens of thousands of destinations, which mean all policies need to be on all input ports everywhere, and that means you're basically putting premium switching in the access layer, which is obviously not tolerable. It's not cost effective. So the way we scale group-based policy in the LAN, there's exceptions to this rule, but within the LAN, policy is applied at output. So at the output port, we know the SGT, the source SGT, it was in the VXLAN header, we saw that before. We know the destination SGT because the endpoint is attached. We can also send SGTs through control plane protocols, not on the wire, but in a TCP socket, just like you advertise a BGP route. It's just a transaction between two networking devices. However, it's not particularly scalable in the campus LAN for the reason I said before. You can't load thousands, or well, you can load thousands. You can't load hundreds of thousands of IP SGT bindings onto access layer switching. It doesn't scale. So control plane protocols are fine. We'll explore some scenarios where they are appropriate to use, but within the SD Access Fabric site, we rely entirely on data plane SGT because it is scalable and fast. All right, how do we put SGT in the data plane? What does that actually mean? It means it is quite literally attached to the original packet, and that the SGT ID, the source SGT, moves with an original packet through the network. We can attach SGTs to Ethernet, so you can see there's a CMD header there, SGT4. The thing about sending SGTs in Ethernet is you need to know that both sides of the circuit support SGT and Ethernet. If I send an SGT to an internet router, it will say I don't know what that is, it's garbage, and your outcomes may vary, but probably it will be dropped because it's not seen as a valid imposition on the packet. So we can send SGT and Ethernet. We need to be careful. You need to be cognizant of what platforms support it. There's a matrix there. You can click on it. That indicates what Cisco platforms support SGT and Ethernet. If we move it up the stack, then the intermediary routing and switching infrastructure doesn't matter, because they're not looking in GRE, for example. A GRE tunnel just moves over the top of routing devices in the middle, so we can stick SGTs in GRE, as an example. We can put them in VXLAN. This is what SD Access uses. So you'll see the group policy ID 4, that's the SGT ID. We'll also see our VNI, so both our macro and micro segmentation context are preserved natively in VXLAN. VNI means layer 3 virtual network ID or layer 2 virtual network ID. So macro and micro segmentation is native to the VXLAN tunnel that moves between SD Access Fabric roles or SD Access transit devices. CMD can also go on IPsec, so in other words, SGT can also go inside IPsec. It is there. Obviously, I've sniffed an IPsec tunnel, so you can't see it, but it is in the packet. I made sure it popped out the other end. So those are our options for moving SGT in the data plane, which is what we will do within an SD Access Fabric site. And you may do between sites depending on the specific conditions. Now, I mentioned that there's some Meraki wireless in one of the sites here. So this demonstration is really a demonstration of what's possible. I'm not saying you would necessarily do all of these things at the same time. You may choose a subset of capabilities here. Maybe you want Meraki wireless everywhere, you go with that. Maybe you want fabric-enabled wireless everywhere, you go with that. Maybe you need a combination. So while we have Meraki in this lab to prove a point, I'm not saying you should definitely do both, because that's obviously confusing. There's a pros and cons list in the hidden slides. Why would you do A or B? So you can give that a read if you want. Please go ahead.
So in the case that SDA access to transit, you talk about different methods of like propagating tags.
Yep.
And so you don't necessarily have to have SGT support on the underlay.
Spot on, spot on. So he's asked, when we're using SD Access Transit, do the intermediary devices need to support SGTs? Absolutely not. So when we have SGT at layer 2 in Ethernet, that means every single hop needs to take that SGT in one port and stick it out the next port. Now you put a HP switch in the middle or an internet router or whatever, it'll say that's rubbish and it will drop it. In a tunnel, They just care about Ethernet addresses and IP addresses, source, dest, MAC, and IP. When the SGT is higher up in the stack, the thing in the middle becomes irrelevant. It could be any router, any switch, we don't care, as long as it routes the packet.
So they don't even have to participate in SXP or anything.
That's exactly right. So something that is moving VXLAN between source and destination, SDA transit, for example, it can be anything. It doesn't need to know what SGTs are, and it does not apply policy because the policy happens after VXLAN comes off, not before it comes off. There is one exception to the rule, of course. When a firewall is SGT aware, it can potentially read that ID out of a tunnel, but that's a discussion for another day. That's quite a complex use case. I probably shouldn't have even raised it because I've just muddied the waters. 99% of the time, the SGTs are relevant to what's in the routed path between the source and destination. All right, so again, Meraki or a fabric-enabled wireless, longer discussion, but if you go with Meraki, which we'll have a look at in a second, in the ICE interface, there is a workflow to integrate ICE to Meraki dashboard. We then define our policy in ICE. It is synchronized to Meraki dashboard, and in this demonstration, deployed to their Meraki locally switched wireless access points. The same would be true if there was Meraki switches in the mix. All right, so we'll get into the next demo. We will connect ICE to Meraki dashboard. We'll create some transits. We'll propagate SGTs, and we'll build a policy. So the goal is to build end-to-end segmentation across fabric sites, within fabric sites, on SD Access Wireless, SD Access Wired, and the Meraki wireless infrastructure. Okay. All right, so two parts. We'll just have a very quick look at the Meraki integration with ISE. Okay, so here in ICE, in order to get the Meraki dashboard integration operational, I mentioned it's a workflow. So we just go to workflow integrations and the Meraki integration here. We can see that there's just a sequence of steps, a brief introduction of how we integrate ICE to Meraki. You can read that at your leisure, of course. What we have here, I beg your pardon, what we have here is if you want to add a new integration between ICE and Meraki, then you click the add button. It's very basic inputs. You just give it some keys and credentials and so forth, and that integration will establish. In this particular case, I've already built the Meraki dashboard integration, so it's operational. Here in the sync selections area, we define what SGTs will be sent to Meraki dashboard. So I've checked these, and it's pretty straightforward. I'm saying send these SGTs to Meraki dashboard for policy. We can see here on sync status that 7 SGTs, 7 out of 7, have been sent from ICE to Meraki dashboard, and 1 SGACL has been sent from ICE to Meraki dashboard. So the integration is extremely simple. It's really just a guided workflow. As long as you know your Meraki API key, the rest is very straightforward. Okay. All right, very quickly in Meraki dashboard, we can see here in the wireless section, I have an SSID, again, my user ID in Cisco in case someone wants to chase me down, and then just the name MR for Meraki radio. In the settings, in the Meraki SSID, here we have, we're saying use my enterprise radius server. So Meraki APs are seeking radius from an on-prem radius server, and for anyone that has an eidetic memory, that's the IP address of the ICE PSN in the lab. So it is seeking 802.1x MAB services from on-prem ICE. Then we can just hop into adaptive policy very quickly. What we can see here is that the SGTs have been learned, so ICE has pushed SGTs into Meraki for reference. And then finally, and this is a bit of a deep dive, I break this down in the slide pack, but finally, I've created an interface profile for the Meraki APs in SD Access. If you're not interested in attaching Meraki APs, just wipe this from your memory. But if you are interested, you'll need to understand how to configure the SD access ports to accept those APs. This is basically a dynamic trunk that comes up when a Meraki AP is attached to the SD access network. And you can see there the CLI propagate SGT. In other words, the SD access edge switches are sending SGTs to the Meraki APs on the wire and receiving them from Meraki APs on the wire. So the Meraki wireless infrastructure implements TrustSec policy, group-based policy, SGT policy, on the Meraki APs themselves. Okay. Now, before I jump into the next demo, I'll just hop back to the slides very quickly, and we'll jump through one more thing. All right, so we've got our Meraki APs. They're forwarding, I'll just go through the sequence and I'll come to you. We've got our Meraki APs connected. They're sending and receiving SGTs and Ethernet towards the SD access infrastructure. How does all this work? Things connect into access ports on Fabric Edge nodes, on Fabric SSIDs, or on Meraki APs. There is a radius transaction. You are allowed in. Here's your VLAN assignment, and here's your SGT ID. So stuff is connected to the network. SGTs move in VXLAN within a Fabric site. We mentioned that before, along with the layer 3 or layer 2 VNI. Over SD access transit, number 2, SGTs and layer 3 virtual networks are again moving in VXLAN. They're moving in VXLAN from borders to edges. And then that last little hop there is sending SGTs in Ethernet because the Meraki APs don't integrate into the SD access fabric today. For the remote site, we need to get our SGTs over SD-WAN. So we will send them in Ethernet towards our Fusion switch. We'll send them in Ethernet towards the Cisco SD-WAN infrastructure. They will move through the SD-WAN architecture inside of IPsec. They will move in Ethernet towards the border node, and again in VXLAN towards the wireless access point. For that point 3 there, SGT and Ethernet on SD-WAN or SGT and Ethernet on border nodes, I linked a product deployment guide in the beginning of this section. So that PDG talks about how to turn on SGT propagation between SD-WAN infrastructure and SD access infrastructure. There's a knob you have to check in the SD-WAN vManage interface, and there's a knob you need to check on the SD access management interface. Is there a question? Yep.
Yeah, so just going back to when you propagated the SGTs from ICE, did that also propagate the GBAC policy?
Brilliant question. When we propagate SGTs, do we also propagate policy? No, we do not. That is a great question. So the policy propagation is, we propagated SGTs and SGACLs into the Meraki dashboard from the ICE workflow. But the actual policy itself is implemented on the wireless access point. It is downloaded through that. Sorry, I beg your pardon. I thought you meant on the wire. Yes, it is. The policy is translated from ICE to Meraki through that workflow. I beg your pardon. I thought you were asking, does the policy move on the wire? But as I think about that, it doesn't even make sense.
Okay.
Yeah.
So I create a GBAC policy update on Catalyst Center. It
Right.
sends it to ICE, and then ICE sends it to Meraki. So I
Yes.
only have one,
Correct. You create policy in Catalyst Center. It arrives in the Meraki dashboard. That's right. Yep. Cool. There is a slight latency. So if you look at the Meraki connection workflow, if you go into that workflow and you hover over the info bubble, it talks about the time frames to propagate that policy. So one thing you'll find is when you change a policy in Catalyst Center, that will be deployed to the SD access infrastructure immediately. It's a little bit slower moving into Meraki dashboard. I think it's in the order of minutes. That's because you can't pound it with substantial policy changes on a second-by-second basis. It's just the nature of sending stuff over the internet. One more question. We do have the Teams room, by the way. I don't want to get us into trouble and run overtime again. Yep.
With this, can you do ACA, so you use a third-party radius server, it still levers the SGTs when it does radius?
Can we use third-party radius with SGTs? Yes.
I knew you can like have a listener, but I wasn't sure if you can on the side.
Yes, so an SGT assignment, can we use third-party radius servers with Meraki doing TrustSec? The answer is yes. A radius assignment is, an SGT assignment is just an AV pair. So as long as you know the AV pair, just send it from your third-party radius server. The trick is the policy download comes from ICE though, so you can't not have ICE, if that makes sense. Cool, all right, soldier on before I get booted out of this room. All right, one more thing. Then we'll get back to the second part of the demo. I've got this example on-prem data center. It is not an SGT-capable data center. So it's just an example of a scenario that happens from time to time. In this theoretical SGT-incapable on-prem computer room or server or whatever it is, we do not send SGTs because it is SGT-incapable. However, what we can do in the template, I'll show you in a moment, on a border node, we can map a subnet or an IP address or a group of subnets to SGTs. So although that external domain doesn't support SGTs, we're essentially proxying it by virtue of this CLI that's been dropped into a border node. So every now and again, someone says, I need to apply policy from endpoints in my SD Access Fabric to some system outside of SD Access Fabric where that system cannot participate in the TrustSec domain. One way of achieving it is to manually load those bindings into the network infrastructure.
Do they show up in the matrix?
Do they show up, I beg your pardon? Do those bindings show up in Catalyst Center? They do not. The other way of loading that binding, and I had a slide here before, I just glossed over it, but I had a slide of previous examples. So in a previous version of this discussion, if you want that binding to be known everywhere, you could load it into ICE and then distribute it from ICE to all the network infrastructure using a control plane protocol. That's a relatively longer discussion, but you can make it known in Catalyst Center, yes. Maybe I'll just add one more detail to that. When you said, is that manual binding that I just configured known in Catalyst Center? The SGT is known in Catalyst Center, but not the particular IP subnet. So we can apply the policy in Catalyst Center, but the subnet to SGT binding is local to that particular switch. If that's a bit of a mind twist, I can unpack it after the discussion. But you'll see in a moment in the demo, yes, I can apply policy to that manual binding. I'll show you. All right, back into Catalyst Center. Let's put all these things together. We've built our Meraki thing already. So I mentioned before, we use transits to interconnect fabric sites. There's multiple kinds of transits, as we saw. There is SD Access Transit, so we'll go ahead and build that ready for reference in our lab. An SD Access Transit really just asks for us to give it a name and nominate what devices will be the control plane node for the transit. So in this particular case, I've just got two standalone switches that will come up as SD Access Transit control plane nodes. In other words, they're just Lisp databases. An IP-based transit is really just two pieces of data stitched together in Catalyst Center, a routing protocol, BGP, it's the only routing protocol you can choose today, and an ASN of a remote BGP peer. So I'll create some IP transits to connect our fabric sites to IP-based transits, to BGP routing domains. So we create, again, I just gave it an ASN, and we'll create some more off camera. And so now we have three transits, three IP-based transits, one for the local data center, one for the firewall, one for SD-WAN, and then one for the pub/sub SD Access Transit. All right. Then we'll go ahead and put these things together. So in the blurb, I said the fabric sites are pre-configured, but we haven't done any of our multi-domain policy yet. So here on a border node, we'll just go ahead and attach an IP transit. So this is the routed interconnect. If you refer to the diagram, it's the routed interconnect between east site and the firepower firewall. We choose what interface the routed interconnect is on, turn on our layer 3 virtual networks. So I'm handing off Corp VN, I give it a local and a remote IP address, turn on some other layer 3 virtual networks, local and remote IP addresses. So this is really just back-to-back VRFs from border node to firepower. We will also attach a routed interconnect to the on-premise data center. In this case, it's just a different interface. Again, VLAN ID, local and remote IP address. So we're routing from border node to our hypothetical on-premise server room / data center. And then the final step here is to go ahead and attach an SD access transit, which is saying I am going to use this to reach remote fabric sites also attached to SD access transit. It's the exact same sequence on the other border node, so I'll skip over it, but we've done exactly the same thing. Attach the firepower, attach the data center, and attach the SD access transit. All right, submit that into the fabric site. Here in central site, as per the diagram, this will use SD access transit. So we will go ahead and attach our SD access transit and submit that. There's no local routing here. The only way in and out of this central site is SD access transit. So what that means is central site communicates with east site over VXLAN. It will then send packets into the SD access fabric, or it will send packets northbound towards the internet or data center. I mentioned before, when you provision SD access transit, it natively deals with VN and SGT propagation between fabric sites. So we've got all of our layer 3 virtual networks and SGTs moving now between central and east site. Finally, west site, we'll go ahead and attach our SD-WAN routed handoff. So in other words, on interface 103 on the west site, fabric in a box, the SD-WAN router is attached. So here I'm just giving it VLAN IDs, telling it what layer 3 virtual networks to hand off, and what local and remote IP addresses are in use. In other words, peer BGP in those 2 virtual networks from the fabric in a box towards the SD-WAN infrastructure. Okay. So that was a bit of a rush through, but basically what we've done, believe it or not, is we have interconnected east site to central site using SD access transit. We've interconnected east site to the local on-premise data center. We've interconnected east to the firepower, and then we've interconnected west into the SD-WAN routing domain. So there's quite a bit going on there. I'm just showing you an array of transit options. You may just choose one of these options depending on your requirements, but I've walked you through essentially the major handoff options in this lab, which is relatively complicated. Obviously, in the real world, you might choose a few design patterns and repeat those hundreds of times rather than creating a bespoke thing per site, obviously. Last thing, there is some templates on the border nodes. I mentioned before that we can statically map SGTs to subnets, so the CLI is there. I'm pushing it through a Catalyst Center template into those border nodes that need to implement this static mapping. The last thing you'll see here is that on the west site, fabric in a box, we've got SGT propagation towards the SD-WAN domain. I mentioned before there's a product deployment guide linked in the introductory section that walks you through why you do this and how you do it, but the bottom line is you need to deliberately send SGTs out of border nodes. They won't do it by default, because we can't assume that the thing outside of the border node is SGT capable, so it needs to be deliberately turned on. Obviously, if you're connecting a border node into your existing network, it may or may not support SGTs, so we don't send them unless you tell us to. All right. Okay. Last thing, we'll build some policy. So we gave ourselves a target policy before. In this particular case, what I clicked there was the cell source BMS. You can see the source cell in the vertical, and I've chosen destination CCTV. So in this hypothetical example, these 2 things are in the same VLAN, but they should not speak to each other. So instead of creating multiple VLANs and multiple routing tables, multiple VNs, instead we can co-locate similar things IoT devices, for example, into a common access segment, and we can stop them from interacting with each other through an SGT policy. So source BMS, destination CCTV, deny IP. We save that, and we deploy it into, sorry, there's one more, I beg your pardon, CCTV to BMS, we'll block that as well, just because in our hypothetical example, in the policy I put in the hidden slides, this was the target. These things reside in the same network, but they should not speak to each other. They're all moving north-south through the SD access fabric towards the data center or a SAS or something outside of SDA. The question came before, can that manual binding be referenced in our policy? You can see that about halfway down, the east_DC_servers. So yes, once the SGT exists, you can build the policy inside of Catalyst Center. So that was the manual mapping I built on the CLI. Okay. So here, what you'll notice is that, again, there's no reference to IP addresses. I don't care if there's 10,000 devices behind these SGTs. They've now been segmented from each other. So obviously what this means is this policy is very easy to create. It's also very easy to modify. So if I wanted to go from deny maybe to permit some TCP sockets and then block everything else, instead of modifying hundreds or thousands of ACLs, I can create one policy, apply it to where these things intersect in the matrix, and that policy is distributed to all SD access fabric sites, to all egress switch ports. All right, we deployed into the fabric, and that's it. The policy is now instantiated on all of our fabric sites, and it's applied equally across all of our access mediums, wired and wireless. And if you were to hear the sales discussion or generally how this is marketed, what we would say is that it is a single policy that applies regardless of where you connect or how you connect. So it moves with you from country 1 to country 2, port 1 to port 2, and so on. All right. We've built virtual networks, we've built SGTs, we've interconnected sites, and we've built a micro-segmentation policy between these sites. Fine. How do I pull in the data center? What happens there? Again, some reference material if you want to look at it. I'm giving ourselves a demo. I'm jumping straight into it. I'll read out the demo, then I'll explain how it's going to work, and then I'll show you how it's going to work. Again, there was a range of data center assets in the lab. They may not all apply to you. I'm just trying to give you a range of options. We are going to use our firewall to build policy between an AWS security group and SGTs. We're going to use the firewall to build policy between the ACI EPG object, that's the ACI group-based policy object, and SGTs, and we'll use the firewall to implement SGT to SGT policy between virtual networks. So in other words, the Cisco Secure Firewall becomes an aggregation point for all of the different segmentation domains, and it can translate between SGTs and EPGs and AWS SGs and other cloud and virtualization solutions. There's a raft of stuff that the firewall can soak in segmentation objects from. This is just some of them. The same principle would apply to Google Cloud or Azure or VMware or whatever. Okay, so ICE knows the SGTs, and we saw before it knows what IP addresses are mapped to what SGTs. We saw that in the introductory screen. When an endpoint connects, it's assigned an authorization profile, a VLAN, and an SGT. As part of that transaction, ICE knows IP address X, the endpoint IP address, is mapped to SGT Y. Cisco Secure Firewall Management Center, otherwise known as FMC or Firewall Management Center, manages FTD. We will send SGTs towards FTD. We will not send SGTs towards ACI, because ACI does not understand an SGT. It's not a meaningful object, and there is no way to send EPGs on the wire. So in other words, 5, IP with no SGT. There is no group-based policy object on the wire between SD access and ACI. We'll use the firewall to take care of that in a moment. Internet is connected to the firewall. We won't send SGTs to the internet. They don't mean anything out there. We won't send SGTs to AWS in this example. They don't mean anything in AWS. There is an exception to that rule, but for the purposes of this discussion, I'll just keep that corner case to the side. We can send SGTs inside of an SD-WAN tunnel, but you need to deal with them. You can't actually send the SGT into the AWS virtual fabric. An SGT doesn't mean anything. They don't have switches to connect workloads. They have something virtual. Now, with all of these things together, Cisco Secure Dynamic Attributes Connector takes AWS security group to IP relationships, or Azure or Google Compute or whatever. It will read in EPG to IP bindings from the ACI domain, and it will read in IP to SGT bindings from the ICE domain. So it is essentially taking in all of these different segmentation domain states, and we can multiplex them inside of our Cisco Secure Firewall policy, I'll show you in a second, to do SGT to EPG or SG to EPG or whatever combination therein is necessary. So all of that information is aggregated and pushed into the firewall. The firewall is essentially cross-referencing IP addresses to policy objects and putting policy between these different domains. I've got a roadmap slide in a minute that will show where we're going with this. What I'm showing you right now is what we have today. Where we're going is a pretty interesting discussion, and we need to start, however, with what actually exists. All right. So I have here, is that rendering correctly? It is. So I have here the interface of Cisco Secure Firewall Management Center. Excuse me, where is this thing? Here we can see that FMC is integrated to ISE. In other words, it is downloading all of our SGTs and IP SGT bindings into FMC. So we'll go ahead and build each one of these policies. So the first thing we'll do is build an inter-virtual network. We saw that the firewall sits between corporate VN and IoT VN in the routing diagram. That means we can build inter-VN source dest SGT policy. To the gentleman's question before, when you want stateful inter-SGT policy, you move this thing through a firewall, and so a firewall can obviously keep track of what sockets have been opened where, and only permit return traffic. So what I'm actually doing here is saying that employees were in the corporate virtual network, and BMS and CCTV, in this example, are in the IoT network. So what I want to say is employees can manage BMS and CCTV devices, but those devices should not proactively contact employees. So to your point before, it is a stateful policy. In other words, what I'm saying in the secure in the Firewall Management Center interface is source SGT of BMS and CCTV is not permitted, is blocked, as you can see in the action, is not permitted to employees. So we have a stateful inter-VRF SGT policy. Again, as we mentioned before, there's no IP addresses in this policy. This is matching roles in the network, so you could have hundreds or thousands of endpoints behind these SGTs. It doesn't matter, because what we care about is group-based access control. Group A should not talk to Group B. Now, I blocked IoT to employee. The bottommost rule there, beg your pardon if we go back a tiny bit, as you can see, the bottommost rule there, it says intrusion prevention connectivity over security. In other words, if it's not blocked, it's allowed. So employees can manage those devices, but those devices can't initiate connections in the reverse direction. Obviously, in a firewall, you can do loads of other things too, IPS, IDS, decryption, and all sorts of stuff that firewalls do that is well beyond my skill set. But obviously, by matching the SGTs, we can then pull in those other firewall capabilities. Okay, so hop into APIC now. APIC is the controller for the software-defined data center. There is an app, well, actually, sorry, I beg your pardon. I'll get to the app in a second. Inside of APIC, we have tenants and VRFs. So we'll just hop into our tenant here and into our VRF. And what we can see here is there is an EPG defined in APIC, an endpoint group. You can think of that as loosely equivalent to an SGT. It is an object that represents a function of workloads in the APIC domain, in the ACI domain. And what we can see here is that there is currently one server mapped to the EPG and ACI called EPG servers. Finally, in ACI, there is this app that I've installed called FMC Endpoint Update app. It's an app published by Cisco. In this particular app, in the APIC controller, we can say that I want you to take your IP EPG bindings out of the server's tenant and send them into the Cisco Secure Firewall Management Center, which is managing my Cisco Secure Firewall. So what we have now in Firewall Management Center is the ability to build a policy where, for example, we can say BMS SGT to servers EPG, so different policy domains, SD access and ACI, is not allowed to communicate. Again, anything that's not blocked, as per the bottom rule, is explicitly permitted. So we are blocking SGT to EPGs. Again, you choose a source of a security group, in this case BMS, and in the case of the APIC Endpoint Updater app, it creates a network object. You can see the same IP addresses there if you remembered it from before. So as endpoints enter and leave this EPG, the object is updated in Firewall Management Center to reflect those IP addresses. So again, what we have here is SGT to EPG policy. Note, once again, we're not referring to IP addresses. We don't care how many hosts are behind those SGTs or EPGs. It's just object-to-object communication. The final step, we'll pull in AWS. This uses a virtual machine. It's available on, it's downloadable off cisco.com or dev.cisco.com. There's a VM called Cisco Secure Dynamic Attributes Connector. It's made by the Security Business Group. In this case, I'm hooking it into AWS. As I mentioned before, it can hook into Azure or Google Compute or VMware or other things. I have an AWS VPC, so I'm pointing it towards AWS. And what I'm saying here is, I want you to match all AWS workloads with the tag AWS servers. Here at the bottom, we get the result of that query. So in this case, there's one IP address that matches the AWS tag called AWS servers. And what will happen is, again, there is an adapter, much like the FMC Endpoint Update app in APIC. It's taking those attributes out of AWS and publishing them into Cisco Secure Firewall. So FMC02.lab is my Cisco Secure Firewall Management Center. With that in place, what we can do here is add our final rule. Again, we are going to block an SGT towards an AWS security group. So once again, create a policy rule, call it block, match a source, SGT of CCTV, and then match a destination destination security group, a destination object of AWS security group servers. So that was added into FMC by CSDAC, Cisco Secure Dynamic Attributes Connector. So what we have here on screen is SGT to SGT, SGT to EPG, and SGT to SG policy. So there's quite a lot going on there, but the takeaway is the Cisco Secure Firewall is the multiplexer of these different segmentation domains. It can map these objects together, and then we can build our policy between the different domains. That's where we are today. We'll get to roadmap in a second. Okay. All right, back to the slides. Okay. Endpoint analytics, for those that don't know, I'm not going to do a demo for this one. I'm just going to give you the pitch because I want to cover some other things. Endpoint analytics is an application in Catalyst Center. If you have Catalyst Center, you have endpoint analytics. It's just another menu, another capability in the platform. So we'll be discussing how we can use endpoint analytics to achieve our microsegmentation policy. Before I go there, Zero trust networking is important because obviously it stops unnecessary east-west movement of traffic between unrelated assets. In other words, zero trust means minimum necessary access for devices, endpoints on the network. I mentioned before the credit card thing, but obviously we can extrapolate to any combination. Things should not talk to things unless there's a reason for that conversation to happen. That is, of course, because we don't really know if they're behaving appropriately minute by minute. Now, in managed devices, like SOE PCs, you may have a supplicant, you may have credentials, certificates, you may know the posture of SOE devices, given that you manage those devices and you control what's on them. So we have high visibility in the network of managed devices. But of course, we also have guests. We have IoT devices, we have contractors and other things in our networks where we don't manage the operating system. We don't know if it's being patched. We don't know if they're maintaining proper security standards. It is essentially at best, an IoT device is probably a semi-trusted device on the network since we don't control it. We need to know what that thing is in order to apply a policy. Is it a camera? Is it a coffee machine? Is it a PLC? What is this thing on the network? So obviously, visibility is important. We need to know what's in our network. Endpoint analytics addresses specifically visibility of unmanaged devices, where we can't peer into the operating system, we can't install a supplicant, we don't know the posture. Visibility is fundamental to zero trust. Once we know what everything is, we need to segment things. We've just talked about that with SGTs and Cisco Secure Firewall Policy implementing inter-policy domain outcomes, group-based policy in the SD-Access fabric, and so on. And then the final thing we need to do is contain bad behavior. If a thing falls out of posture or it starts behaving in a negative way, then we need to be able to adjust its segmentation policy in runtime, kick it off the network, cut it off at the knees so it can only access a remediation server, whatever. Containment means whatever you want it to mean, but essentially change its policy at runtime. Endpoint analytics, so we've done segmentation. We'll get to containment in the next section. Endpoint analytics is firmly in the visibility bucket of the zero trust architecture for unmanaged devices. As I said before, if you have Catalyst Center, you have EA. Endpoint analytics is just a menu in Catalyst Center. Catalyst Center consumes telemetry from the network infrastructure as endpoints transact. It will cross-reference what ports, protocols, and attributes are being generated by endpoints, and we'll reference that to our device profiles and endpoint analytics. So we can say, based on your behavior, you're probably a Meraki camera, or based on your behavior, you're a Apple TV device, or whatever the case may be. There's an uplink to an AI ML engine, so unknown things are sent into the cloud. There's some magic that happens back there, some crowdsourcing and attribute collection. And so the idea is, as more and more things connect into endpoint analytics, we either know what it is, or we send that data off to our backend, and we try and work out what that thing is. So as more stuff connects into endpoint analytics, more is known about that stuff. Now, once endpoint analytics profiles a thing as a coffee machine, an Apple TV, Meraki camera, whatever, those profile labels become usable inside of ISE. So as endpoints transact, obviously I said before, managed endpoints, we know what they are, but for unmanaged endpoints, as they transact, we build models of what they are, and we reference those models inside of our ICE policy. So this is from the lab, and the policy is applied. So for example, if you look at the top row, a thing has mapped into an SD-Access switch port. In other words, it doesn't have a supplicant, we don't manage it. We have matched it in endpoint analytics as type streamer made by Apple. As a consequence, I can assign that to a particular VLAN and a particular SGT. So VLAN IoT, VLAN IoT, SGT TV in this particular case. Now, obviously, it represents something substantially more powerful than managing databases of MAC addresses to affect MAB outcomes. It's better if we can just say, map these roles to these networks with these segmentation objects. I won't do the demo here because I want to get onto the roadmap a little bit. I did deliberately not include this demo in today's discussion. It is, however, in the Teams room for today's discussion. If you want to look at how endpoint analytics works, it's also referenced on the previous iteration of this presentation on CiscoLive.com, and I've hyperlinked that at the end of this section here. So what does it all boil down to? Unmanaged devices connect into the SD access fabric. They start to send and receive information. They're given a level of network access. Maybe they just go to a quarantine network, as an example, or low access, restricted access, whatever it may be. They start to send and receive packets. The switching and wireless infrastructure generates telemetry and sends it to endpoint analytics application. It determines what these endpoints are, makes an assertion, sends those labels, this is what I think the endpoint is, over to ICE. ICE will then, as endpoint labels change, will re-authenticate and reauthorize the device. So you saw before that policy will be reassessed. It will now match Apple, for example, and will drop into the network associated with Apple TV. So in other words, when we change a label, ICE reruns the policy and changes the authorization on the port associated with that MAC address. The narrated demo is here. The unnarrated demo is in the Teams room. Two more things. We'll power through XDR very quickly. We'll do roadmap and then we're done. I want to finish on time. XDR consumes telemetry from network infrastructure, both Cisco and non-Cisco and adjacent systems, and it will look for security events and prioritize the severity of those security events. So in other words, it gives you a SaaS-based UI where you can see major incidents on the network and choose to investigate or act on them. I'll give you a quick demo of how XDR works. This is the containment component of the Zero Trust architecture. So things are on the network, but now they're going to start acting up, and we can see how we respond to them. There's two examples in this demo. I could do hundreds, but we'll just cover two. I've got our security agent on one of the endpoints, Cisco Secure Endpoint. As things happen on endpoints, Cisco Secure Endpoint uploads security events, file hashes towards the cloud. XDR, which I'll show you in a moment, can consume event feeds out of Cisco Secure Endpoint. Endpoints use DNS to talk to things, as people know. Umbrella is our, well, it's more than DNS, but for this example, Umbrella will deal with DNS security. These DNS requests represent untrusted domains or known threats on the network. Umbrella, again, an on-prem agent, sends DNS towards Umbrella Cloud. XDR, again, can consume information out of Umbrella Cloud. XDR can consume information of literally hundreds of other sources. I'll show you in the UI. I'm just showing you two, but extrapolate this to whatever your favorite tools are. There's probably an interconnect you'll see in a second. It consumes the information you give it, prioritizes security events, and if you want to take action through the XDR user interface, you can manually quarantine an endpoint, or you can automatically quarantine an endpoint depending on its behavior. XDR can talk back to ICE APIs and say that endpoint is a problem. You need to set a flag or you need to take action on it. That's called ANC. In other words, XDR sets an ANC flag on a particular endpoint or a group of endpoints. When an ANC flag is set in ICE, Adaptive Network Control, when that flag is set, ICE can match that flag to take remedial action. I'll show you in a second. Basically what it boils down to is endpoint misbehaves, XDR notices and changes the access of the misbehaving endpoint, either manually or automatically, depending on how you want to manage your network. There's a fair bit to that, but essentially what we're dealing with is runtime quarantine of misbehaving endpoints. All right, I mentioned ANC before, so we can see here that there is a new rule across the top. We're saying if it's wireless 802.1x, and a user group is matching a particular identity, and it has an ANC flag set of whatever, I called mine quarantine, then we're going to put it into the network it was already in, but we're changing the SGT to quarantine SGT. So in other words, the endpoint retains access, but its level of access is restricted because it will start misbehaving. That restriction can be completely kicked off the network, or perhaps just minimized access in order to reduce the amount of damage it can do. Quarantine means whatever you want it to mean. It doesn't mean banned, it might just mean reduced access. All right, so here I've added some policy here. So I'm saying quarantine SGT can't talk to anything. So that means all switches and wireless access points in the SD access fabric, if they see a packet from quarantine SGT, they'll just drop it. That's east-west within the SD access fabric site. In the firewall, I've added some more rules. I've said quarantine SGT can talk to Cisco.com and 4.8s. So think of this as restricted access. Maybe they can just download a patch, or they can just access some reduced number of things that you're comfortable for misbehaving endpoints to talk to. Again, it just depends on your security policy. What I'm trying to say is you can restrict access. You don't have to ban access. It's all just policy. All right, so XDR UI, what we can see here is there is a group of events on the right. Sorry, hang on a second. Let's just get to it here. I mentioned before XDR is a SaaS platform consuming security data. Here is the list of integrations. As you can see, there's far more than we can possibly go through. In my particular case, I've integrated to Cisco Secure Endpoint and Umbrella. There is obviously hundreds of other integrations here. I'm just scrolling through to give you a sense of what's going on. So the ability to collect data about security events on the network is substantial. What I have here is a policy. I'm just going to zoom through this. I have a policy in order to, or a target rather, to say I'm going to send security remediation events towards ICE. There is two potential security actions we could take. One is manual. These are self-constructed workflows. So in this workflow, when I fire this workflow, I give it an IP address. It will take that IP address and send it to ICE to say, apply an ANC flag to this IP address, which means it's re-authenticated and reauthorized. And we saw before, ANC translates to security, to quarantine SGT. So this action is called manual. This action is called in a manual manner. We can also automate responses inside of XDR. So in the case of an automated response, we feed it what XDR calls an incident bundle, which is a JSON bundle that represents a security event on the network. In this case, I build a manual query. You can see there in that box where the mouse is. In this case, I'm querying the JSON bundle, looking for the source IP address of the device that triggered the incident. So with that, we'll go ahead and we'll do some stuff on the network in order to create some security events and responses. You can see here on this screen, the last event was 20 days ago, so this is just me preparing in order to build the demonstration, but those are historical events that have been actioned. Okay, so first of all, on the left-hand endpoint, this is an endpoint connected to the SD Access Fabric. It's a wireless endpoint. What we'll do here is go ahead and download a virus sample file. So you can just, this is one of the few that Cisco will actually allow through the network, but it's enough to trigger a Cisco Secure Endpoint. So you can see there, this device, which is running Cisco Secure Endpoint, downloaded eicar.com, but it's missing from the PC. In other words, Cisco Secure Endpoint has seen a file hit the box, it said, I know that's malicious, and it's wiped it. What's also happened, though, is Cisco Secure Endpoint has sent that file northbound, and it is now That security event has moved from Cisco Secure Endpoint into XDR. You can see source, Cisco Secure Endpoint, 1 second ago. We can investigate this issue if we want. We can zoom in. There is, this device is currently sending traffic to the internet. You can select the IP address of the device, and you can choose to manually quarantine this endpoint. So when we take this action in XDR, what we'll see is that that endpoint is immediately kicked off the network. So it's lost access to 4 nines. That's because the ANC flag has been set, it's been reauthorized, quarantine SGT has been applied. The right-hand side is the same thing, except that, and I'll skip the right-hand side so we can wrap up on time. The right-hand side is the same thing, except that it is an auto-quarantine response. On the right-hand side, I'm accessing a known malicious URL, and that URL is blocked by Umbrella. Umbrella reports the event into XDR. We'll just zoom through this here, and what we'll see is there is a security incident of priority 1000. Anything above 100, anything above 500 is auto-quarantined. So this endpoint is already booted off the network. We didn't have to take action. So you can manually respond or automatically respond depending on the severity of the security event as interpreted by XDR. Last thing, and we are going to finish on time very, very quickly. ICE has obviously been central to most of the discussion here. You may have heard the language of common policy at Cisco Live. If you haven't, well, I'll introduce it now, but if you have, this is what it is. Common policy is roadmap. So you can't turn it on today, mostly. There is some corner cases. Common policy is roadmap, but what is it really? It is context exchange to enable microsegmentation across different networking domains. ICE is central to common policy. There are some things that are developed. There are some things that are going EFT shortly, GA hopefully later this year, and there's some things that are further out. Ordinarily, we don't do roadmap stuff at Cisco Live, but I want you to know where we're going so we're all on the same page. ICE integrates the Catalyst Center now. Information is exchanged between those things. That is not common policy. Catalyst Center itself is not a networking domain, okay? Context exchange between ICE and network infrastructure, that falls under the bracket of common policy. It's context exchange between different domains. We can send SGTs and IP addresses into network infrastructure. We used SXP as a common policy object to interconnect our firewall. We use PXGrid to interconnect our firewall. SXP is also there for other use cases. We used some of the Meraki interconnect. There's 2 parts to this. The first part is just policy object exchange, SGTs and SGACLs. We did that today. That is not common policy. There is no context in that. It is security objects, but it doesn't tell you the addresses of the endpoints that map to those security objects. That's why we had to put Ethernet on SGT and Ethernet on the wire. The next part of the Meraki common policy, and I've underlined the word roadmap there, so we're all on the same page. The next part of common policy is to send IP SGT bindings directly into Meraki dashboard, so we don't necessarily need to move SGTs on the wire between these domains. It doesn't exist yet. It's under development, so we won't get into how to design that until it actually really exists. But in general, you can bypass SGT on the wire in some Meraki use cases once that exists. 2 bold roadmap things here for common policy. ICE will we have it in the lab already in beta. ICE interconnects directly to APIC. SGTs are mapped to EPGs and EPGs are mapped to SGTs. So we can build that inter-SD access to ACI domain policy without putting a firewall in the circuit. You can still put a firewall in the circuit, but if you don't want to, you don't have to. It's no longer a dependency. The objects translate between the 2 domains through this ICE interconnect. There is a hook into virtualization providers as well. So this is what we did with CSDAC. This is also a roadmap. We will download those security grouped IP bindings from Google Cloud, Azure, et cetera, VMware. Those security groups will become SGs, security group tags in ICE. So again, CSDAC is out of the circuit. The firewall is not a mandatory component. You may still want a firewall, of course, to do the great things that firewalls do, but technically speaking, that architecture is no no longer required firewall and CSDAC to load policy in from cloud to ICE and into the SGT domain. ICE and SD-WAN already exists. We already send IP SGTs bindings into the SD-WAN architecture. We didn't cover it today, but the common policy SD-WAN interconnect exists. ICE and Secure Services Edge, that is coming later. In that case, we can reference SGTs in the SSE architecture to build policy from endpoints in the campus to, or endpoints in the data center or whatever it might be, to things outside of the SSE. So very quickly, with only 2 minutes over time, it's your feedback that keeps this thing going, so please keep telling us what you need. If something is missing, make a wish. There's a knob in the Catalyst Center UI. We've had some customers talk about SD Access this week. You can watch those recordings later. There's more SD Access tomorrow. The sessions are there on the roadmap. Please finish the session surveys. If this is useful, let me know. If you want something different, let me know, please. And with that, I'm going to say thank you very much. Have a wonderful day.